Stephen J. Gould is joining us now. You're a prolific and very popular writer. I was amazed to see how many books you actually had in press now. What's your book total?
It's about 20 books that I've written, but I wouldn't exaggerate the significance of that. If you write essays every month, as I have since January 1974, they automatically accrete into books every 3 years or so. So 9 of those volumes are collected essays from that series. There'll be a 10th and final one, because I'm going to start writing them at essay number 300 in January 2001.
Oh, nice. You'll be sorely missed because you are popular, and I feel like you're a man on a mission, with a mission to teach us how to do evolution and think about evolution correctly. Is that one of your goals?
If I have a mission, and this may sound not exactly what you expect of people, but if you ask any writer in an honest moment, nobody will tell you anything different. I write those essays for myself. Any good writer has to. That is, of course I want to facilitate learning. Everybody does. I think that's great. But I think if you did it only because you felt some desire to impart something to other folks, you weren't doing it out of a deeply internal need. You could only do it for a while. Once you got successful at it, there wouldn't be an impetus anymore. I think any decent writer writes because there's some internal need to keep learning and to keep trying to write the perfect essay, which is impossible, but about 1 in 20, I think, after I finish it, well, that's about the best I can do. That's good. The others are okay.
What are the attributes of your favorite essays, the ones that you think have captured something?
The ones I like best usually take up an unknown or an odd subject, something no one's ever written about, but since most things nobody's ever written about are truly trivial, if you can use something that's interesting and unknown to illustrate a larger generality, then I really get pleased. Or sometimes if I read a very common text and realize that it's been misunderstood universally, it's amazing how much remains to be discovered, even about the most visible and obvious things. Human beings are sheep. We tend to believe what we read and do things in the same way. I've been told by good anatomists that there are still things to be discovered about the anatomy of frogs, even though millions of them have been dissected by school children and others since the 17th century. It is amazing what remains to be learned. So probably the essay I'm most pleased with is the one I wrote about Leonardo's paleontological observations. They had never been understood. They'd been read in a wrong context. And I think I figured out, because I know the history of paleontology, I think people, Leonardo scholars who'd approached those hadn't really known enough paleontology to see the context of what he was really discussing.
It's very interesting to me because, as you talk about this, I was going to use the term celebrate. I often think that you celebrate how we can look exactly at something and not make a correct interpretation. Earlier today, you talked about theory versus narrative. Can you explain what you meant by the difference in those two things?
I think you should celebrate the whole history of human knowledge, and after all, the story of our species is not a happy one with its inquisitions and genocides. What's so interesting about Homo sapiens is that we do the most horrible things to each other, but every once in a while we do incredibly noble things as well. And I think the history of the accumulation of scientific understanding is one of the bright spots. Science includes a lot of activities. On the one hand, we want to develop general theories about the way the world works, but we sometimes make the mistake, especially those of us interested in the natural world, of thinking that the highest task of science is the development of very abstract, timeless generalizations, the so-called laws of nature. But when you're dealing with history, a lot of the most important material that you need to understand is not directly deducible from laws of nature. In fact, it's just what happened to transpire. And history works that way. It's unpredictable, it's contingent, and it's enormously complex. It's not mysterious. After it happens, you can explain it, just you can't predict it beforehand. That's the nature of complex historical sequences, and a lot that we want to understand about the history of life is not a direct deduction from the laws of nature, but emerges out of the contingent narrative of what happened to occur one way but could easily have occurred other ways under nature's laws just didn't have to. The very fact that human beings are here, for example, is not predictable under the laws of Darwinian evolution. It happened as a result of a whole set of luckily contingent circumstances, including the removal of dinosaurs by a large extraterrestrial impact, absent which I don't think we'd ever have evolved.
You talked about in this your interest in an almost statistical kind of look at probabilities and the improbabilities of life and evolution. You're one of the most statistical thinkers among the popular writers. Is that hard to convey?
The main reason that statistical thinking is very hard to convey is that the human mind doesn't work well with probabilities. I think that's one of the most extraordinary and pervasive hang-ups. It's probably deeply wired into the way the mind works. The mind basically is a pattern-seeking machine. I think that's true of our ancestors as well. We've grafted consciousness onto that, so we tend to seek pattern because that's what mammals do, as a lot of creatures do. But then we tell stories about them. So I think we're pretty much conditioned to look for pattern and to try and interpret in terms of certain stories. Now the problem is that a lot of what happens out there is effectively random. You get patterning in random systems, like the clumping of stars into constellations, which occurs because they're distributed at random with respect to the Earth's position. And we are just very bad at statistical thinking, naturally, because we're always trying to tell causal stories about the patterns. To understand statistical issues, you really have to train yourself. But that's what education's all about. We're not incapable of doing it, but it goes against the way we naturally think about things. So when you make statistical arguments, you have to be very explicit and choose good illustrations, but it's certainly conveyable.
In some ways, you're very like Ernst Mayr, who's been honored at this meeting because of your deep interest in history. You talk about him and his place in history. Who are the great scientists of the last millennium?
The whole millennium? Give me a field.
Well, biology.
It's hard because biology itself is so broad, but if you want to restrict yourself to the study of natural history and evolution, the whole animal sciences, I probably would start, if you just give me this millennium, with Albertus Magnus, who's the best of the medieval thinkers. Now, not many of them are very much inclined to make extensive observations of the natural world. They're mostly commenting on Aristotle and Averroes, or Avicenna, the Islamic commentators on Aristotle. They're not doing experiments, but Albertus brings the wisdom of the ancients to the Renaissance. And in the Renaissance, you have some great compendium writers, people who write down everything that's ever been said, true or false, about organisms. Conrad Gessner in Switzerland and Ulysses Aldrovandi in Bologna, the two greatest, both 16th century thinkers. Leonardo was enormously important, except none of his stuff was published. It's all in his notebooks, so it had no influence on the history of science, because by the time it was finally published in the 19th century, it had all been discovered. He stands there as a remarkable figure. But then you move up into the 17th century, into Newton's generation, and just beyond, you begin to get a more modern natural history and the Enlightenment, the age of classification. You get Buffon in France and Linnaeus in Sweden, the greatest mid-18th century natural historians. And then as you get into the 19th century, you begin to get rudimentary understandings of evolution and Lamarck, and it finally culminates in Darwin in 1859, and I wouldn't exclude people just because we think their theories were wrong. Cuvier, who starts the science of comparative anatomy, wasn't an evolutionist in the early 19th century. And then Darwin in 1859, that's such a watershed. It so resets the way in which people look at the history of things. In a sense, once you discover the basic factuality of evolution, almost nothing that big can be found again. But when you think of how much we've learned since then, in fact, Ernst Mayr represents a whole generation of people, including Dobzhansky and Simpson and Stebbins and others whom he mentioned this morning, who modernized the theory of evolution in this century.
You talked about four main issues or questions that you think we've made remarkable advances in since the 125th anniversary of the publication.
No, 100th of Darwin's death.
hundreds of Darwin's deaths. What were those?
Well, Darwin died in 1882, so I was trying to just look at what's happened in only 18 years since the celebration in sort of 1982, and I thought that the four areas were most important were first what we've been able to do with genetic analysis for studying phylogenetic and cladistic orders and sequences. Amazing what we've sorted out the relationships among the invertebrate phyla, which I didn't think was doable. The whole phylogenetic tree of bacteria has been not only resolved, but it looks as though the lateral transfer that occurs pervasively is going to upset the whole Linnaean style of classification, which is hierarchical and based on branching. And if you have lateral transfer, you can't apply the system. And then secondly, I talked about advances in the evolution of development. I wrote a book, my first book, on ontogeny and phylogeny, and I was absolutely stuck at the end of it because we could say nothing about the genetic basis of development. And now we've made the most amazing discoveries, of which the most surprising are the homologies or shared genetic patterns and programs of phyla that have been separate for 500 million years, particularly arthropods and vertebrates, which I did not expect to find, though I rooted for it. Thirdly, I talked from my own field of paleontology about major discoveries and understanding the narrative history of life. In 1980 was a radical theory that you might have had catastrophic mass extinction produced by impact of large extraterrestrial bodies. Now it's virtually a fact, at least for that one extinction, for which is well documented, the one that made our life possible by wiping out dinosaurs. And then fourthly, I talked about experimental evidence, microcosmic, so to speak, but with enormous implications, the study of 25,000 bacterial generations, because they go so quickly, and other related items. It's a wonderful time for evolutionary theory.
And where are we now in science? What do we need to do to have a vibrant science?
We have a vibrant science. We need to keep going and continue this integration among the disciplines. 20 years ago, people would have said genetics and paleontology represent two opposite ends of the spectrum and have nothing to say to each other, and now these fields are virtually united by using the fossil record to help figure out the phylogenetic and cladistic patterns that are inferred from the analysis of relative genetic similarities among living forms of different phyla. I think if we can continue that and continue to integrate and build a more complex general evolutionary theory, we will carry on.
You've been involved not only in popularization, but you've been involved in paleontological work that was controversial in its own right. Well, what's happened to punctuated equilibrium theories, and where do we go with those kind of ideas?
Punctuated equilibrium first appeared as a doctrine of that name, so to speak, in 1972, although bits and pieces of the ideas had floated about before. I feel very good about it. It's almost 30 years now. There's still no consensus about its relative frequency, but there's no doubt that the phenomenon exists and has some elegant demonstrations. I guess what I'm most happy about are two things that have come about as a result of the debate of punctuated equilibrium. First, we've convinced the world of evolutionary biologists that stasis is a real phenomenon worthy of study. Before punctuated equilibrium, nobody studied the stability of lineages. It was just seen as disappointing evidence of non-evolution. I don't think you could cite a single quantitative study of species that stay stable, and yet that's a fascinating phenomenon, and that's a concept that has entered the theory. And secondly, the need to think evolutionary pattern in terms of the differential success of species and not the slow and steady transformation of populations. And as populations are stable, requires a completely different way of looking at trends in the history of life, and I think that has been widely accepted. Also, since the main thrust of the theory in terms of practice was to convince paleontologists that they had a much better record than they thought, and that when they saw surprising results, it wasn't always as a result of the imperfection of the geological record. It might actually be recording how evolution occurred. I think we've got the science of paleontology to respect its own record better, and I think that's been very salutary.
You said that you're going to soon in the next year or so, give up writing your monthly column, what are you going to be writing?
Oh, all sorts of things. It never stops writing. It's the Michael Jordan principle. You should quit while they still want you.
Thank you. You're very popular and amazingly respected scientist for someone who does evolution. It's really amazing, and I'll just ask you, well, I'll start and ask you a question. It's really amazing that you're such a popular writer and your works have been so widely used, accepted, and celebrated. Yet you write about evolution. Do you find a contradiction in that, given some of our current conversations about the role of evolution in education?
Why should it be contradictory that writings on evolution be popular? Creationism is a small dogmatic minority in this country. I think they make more noise than their numbers, and it is a distressing issue, and it's true that the vast majority of Americans don't know a whole lot about the history of life and don't think a lot about evolution, but it's such an intrinsically fascinating subject. The majority of Americans are very favorable towards science and very interested in it, and there's hardly a concept that's been discovered by science that's more intrinsically exciting to people than evolution, the study of how life came to be as it is, why there's so many kinds of organisms, what are humans related to, how do creatures interact? No, it's always been a subject that, however controversial to some people, has been immensely fascinating. In fact, I think it's a great advantage to write about evolution. I don't know that you could write 300 monthly essays on the physics of elementary particles, but you can certainly do it on natural history, which is as diverse as the millions of organisms out there.
I want to thank you for giving us this interview today. Thank you.
Okay.